Yeah, this is going to be something a little different. This will almost be vlogish because I've sort of been collecting parts for a few months because pandemic. I mean, it's not like you can buy video cards and stuff like that. But water cooling is what I want to talk about, and it's specifically water cooling small form factor machines, because building a custom loop for a small form factor machine, it is kind of a lot of fun. You kind of get sucked into this, you get the itch, and then all of a sudden you're spending hundreds or $1,000+ on a custom loop cooling system. You know, I don't know, you probably would be better off spending a bunch of money on the actual system. But I've had a surprising amount of fun, and I just wanted to share some fun stuff. Alright, so building a custom loop for your desktop doesn't even necessarily mean hard line. Like, the bug hasn't bitten me to the point where I'm super interested in doing hardline builds. Like, I see all the other, like, you know, the big YouTubers building hardline, and my builds tend to be more utilitarian. There is an EK Pro kit, which is by far and away my favorite, you know, desktop cooling kit. It's the one that has the quick release system and the distribution block. It's in a Threadripper build. I still use that system. I use that system every single day to do Threadripper-y things because Threadripper is very freeing. It basically makes it easy to quickly add and remove peripherals. Instead of having one giant loop, the pump goes into a distribution block that hits the radiator, and then you can add and remove peripherals as you need. The way that I built it, the CPU is always permanently connected, but I can have up to 3 GPUs connected to my block otherwise, and they're quick release. So it's easy for me to take a GPU out, put it in another system. It's easy for me to upgrade GPUs without even changing the loop or doing anything like that. But it's in a full-size desktop system, so it's really easy to do. You get something like this. This is the MSI Z590 Carbon EKX. So EK, which is a big name in PC water cooling, and MSI, which is a big name in PC components, have teamed up, and you can buy something like this. This is the Z490 version. I reviewed it. Also reviewed the Z590. This comes with a monoblock, which is basically just a fancy way of saying this is your CPU block, plus it also touches the VRM on the motherboard. So this basically keeps everything on the motherboard cool that we care about. Now, everything else on the table, some of the stuff on the table is on loan from my friend Joe, but everything else I bought at Micro Center. It's fun stuff. When you're building small form factor, custom loop stuff kind of goes out the window. In addition to the EK kit, there are also kits like this Thermaltake 360 DDC soft tube liquid cooling kit. And so when you've got something like this, what comes in the box, you get a 360mm radiator, 3 fans, a block for your CPU, usually some, you know, throwaway RGB kit, tubing and fittings for connecting the tubing to everything, and then a pump reservoir combo. Technically, you could run a pump and a reservoir separately. Like, there are some people that do that in their custom loops, but generally they come as one thing. One thing that I really like about that Thermaltake kit is that it comes with a fill bottle and some other nice things that are good quality of life improvements. Things like there's a fill port here on top of the radiator. It's raised and knurled, which means that it's got grips on it so that you can grab a hold of it to unscrew it with your hand. You don't always get that. And this pump, look at this pump, it's super tiny. It's so little. This is a DDC pump. Don't assume that all DDC pumps are exactly the same. The DDC pump that comes with the XSPC kit, for example, is different physical dimensions. But this pump and this SwiftTech pump are also really similar in terms of physical dimensions. The pumps are different, they're different brands. This one's Xylem Service Hungary, but you know, if we look at the back of it here, they're exactly the same dimensions. This is a pump only. So notice we've got an inlet and an outlet on the side. There's no reservoir here. You would have to run that separately. Whereas with this one, the reservoir is on top, and then the exhaust is there, and the inlet is here. So the inlet comes down and goes around, and then this is a fill port. This is sort of a second inlet, if you will. There's also D5 pumps. So that's like these. A D5 pump is a sealed pump. A DDC pump is a direct drive for the motor. So if you look at this, you can see the motor. There's a pin there for the motor on the back of it. The motor shaft turns, it's connected to the thing that moves the water. It's direct drive. So the water pressure in these is pretty enormous because the motor will turn it. But the thing that is moving a lot of water is typically physically pretty small because the motor has to be able to move the liquid. So high pressure, lower volume typically. The D5 pumps is a hemispherical sealed motor. So we use the power of magnetics. And the thing that moves the water is moved magnetically, so that the part of the motor that the water is in contact with and the part that the electronics are in are physically isolated from one another. There's actually a ceramic bowl, and then a hemispherical impeller sits in the bowl. And it sort of relies on water entering the bowl and lubricating things and keeping everything running, and also helping cool the electronics. Electromagnets around the perimeter of the ceramic bowl is what moves the impeller because of the permanent magnets that are installed in the motor. That moves a tremendous volume of water, but it's not super high pressure. It can't, if the water has a lot of resistance because you have a lot of turns and bends and stuff like that, or if you have, a lot of stuff or it's physically very long or you have a big case, it doesn't work quite as well. You can do loops that have custom, configurations where you have multiple pumps. That's totally a thing that you can do for redundancy or just additional pressure or flow. But in small form factor machines, it doesn't really work that way. If you've got a small form factor machine, something like this thermal tank combination pump and reservoir is not really the most efficient use of space. Check this out. This is 92 millimeters across and has mounting holes such that it will mount on the outside of a case. Here's our Incase M1. This is an insanely popular case among builders because it's insanely compact, but it's not too much of a pain to build in. As you can see here, we've got, rear mounting holes for a 92 millimeter fan, and then we have our rubber grommet holes for, liquid cooling. This is where this thing is so cool. You can mount it on the back of the case. It doesn't take up any room internally. It doesn't really make the case any bigger because you need those clearances in order to be able to install cables and things like that. This works shockingly well as a reservoir solution for a small system like this. The pump ends up being located here. And so you mount a pump like this SwiftTech. Like the SwiftTech pump, you take off this little inlet outlet piece of plastic and the pump will mount right there. This is from Iceman Cooling, and they sell a version of this that comes with a pump. Sometimes you can find the version without a pump on sale. That's what I did. It was absurdly cheap compared to the version with the pump. It was easier for me to get a $60 SwiftTech pump and just do it myself than pay an $80 difference, between the two. But your mileage may vary. This is really cool because I've got a knurled port on the top as well as one on the bottom, and I can drain. Like if I unscrew this and I want to drain my loop, I can drain it, back here, and it's really easy to deal with. I don't have to mess with the innards of this thing at all, even though the Incase M1 doesn't have a fill port or anything that's really accessible. I mean, I guess theoretically I could pop the top off and mount something in here and blah blah blah, but look, I'm lazy. I want it to be as easy as possible. This has been the absolute best solution for the Incase M1. Now over here I've got the Cooler Master NR200. This case is an order of magnitude less expensive than the Incase M1, and it's not really a lot bigger. I mean, alright, here's our Incase M1, there's our NR200. It's a little taller, it's a little wider, and it's a little deeper, but not a lot, just a little bit. And that little bit makes a huge difference. For one, you can actually get a 280 millimeter radiator in here. That's, you don't want to do that in the Incase M1. You can get two dual radiators in both of these. Man, it's a challenge, but doable. It's so tiny. The Cooler Master NR200 supports SFX and SFXL power supplies. If you wanted to save a few bucks, this is a no-brainer. But you gotta admit, the aesthetic. This is available in black. I did a video on the black one ages ago. This one's the aluminum one. Got two USB 3.0 and USB-C on the front, plus headphone. I haven't even installed the front panel yet because I'm not exactly precisely sure how this build is gonna do. And like the Incase M1, we can cheat a little bit. We've got our 92 millimeter reservoir here. Guess what? Those fan holes on it are also 92 millimeters. Now the part where it doesn't work out so good is our inlet and outlet holes do not line up on the rear I/O of the Incase M1, but fortunately there are punch outs here. So you only have to drill one hole, just one. And I recommend that you do that before you install your computer, because all those little tiny conductive pieces of metal will be very bad for your computer. But installing the pump reservoir outside of the case is pretty smart. Now some people will say that DDC pumps are louder than D5 pumps. Historically that was true, but modern DDC pumps, in my experience, they're about the same. Sometimes you can run them at higher RPM, but if you've got pretty good motherboard fan control, and motherboard fan headers that support 1.5 amps and on up, make sure that it can do at least 1.5 amps, at least 2 amps ideally on those pump headers, because some of these will use a lot of power. Our SwiftTech, for example, SwiftTech's 1.5 amps. So 1.5 amps, 2 amps, something like that. If you have a motherboard fan header that'll do that, you can run those pumps, 500 RPM, 1000 RPM under their max, except when everything is at really high load or you've got ridiculous temperatures, and it'll be really quiet. That's one of the things that you get with doing a custom loop with this. If you do it right, you actually can end up with an insanely quiet system. Way quieter than you could get with tower cooling, especially in a small case like this. Way quieter than you can get with an all-in-one loop cooler as well. I personally, you're embarking on something that is a headache. It's like having a pet. It does require care and feeding. You do have to jump through some hoops, but it's kind of a fun hobby. It's like, do you want a pet? Well, maybe you get something fun and emotional out of that. I don't know, maybe you get that out of your computer. What's wrong with you? What's wrong with me? What's wrong with all of us? I don't know, but this works really well for that. Now, hang on a second. I found this thing from EK, the EK Quantum Kinetic. And they have several pumps that are labeled Quantum Kinetic. Or like this one, which is the EK Quantum Kinetic, which is just a bigger, nicer version of the one that I showed you from Thermaltake. Also costs a lot more. So this one, check it out. This is a 120 millimeter version of this. Bigger reservoir, the pump is included. This is like $150, $200, something like that. But you've got more inlet and outlet ports. You've got an inlet and an outlet on the bottom of this, but you don't have any on the back side here. They're all on this side or on the bottom. So you've got to sort of plan your build pretty carefully. This is kind of strange, I think, because EK, if I'm gonna mount this against the back of the case like this, then these could go directly into the case and it'll be fine, but I don't really have a convenient fill port. The fill port is facing the inside of the computer. If I mount it like this, which I think is how they intend it, because the mounting kit will actually hold it on the sides here, and my screw holes are here, so this can be flush against the back of the case with just a little bit of a gap here. And then my in and outlet can come down and go in the computer case this way. So it would be mounted like this, and then I would have my tubes here and here. Again, I'm gonna have to use the punch out, probably make my own hole. This is obviously designed for 120 millimeter fan mounting, but because we've got a little bit of room to work with at the back, I can just 3D print a 92 to 120 millimeter fan adapter. There's actually a bunch of those on Thingiverse. If you just search for 92 millimeter adapter on Thingiverse, there's tons of fan adapters there. You can take one of those, 3D print it, repurpose it, and then you'll have a nice holder for this. It clears the cables, it clears the side of the case. This is great because it still gives me that thing where I can do the draining external to the case, and I can do the filling external to the case. I don't have to take it apart. The only thing that's unfortunate is the placement of the inlet and the outlet, because if it's in this config, I'm not going to use these. Not at all. Just not going to happen. In a larger case, this could be useful because you could mount it in the front. So like those fractal cases, you could actually mount this in the bottom front of one of the fractal cases and not give up any room internally at all. And then you've got your inlet and your outlet here. This could actually tie into the fill port so that your reservoir here. And this is a perfectly reasonably sized reservoir. Yeah, it's not as much of a fluid reservoir as you have with the giant cylindrical tanks, but if you've done a pretty good job building your loop, you're not going to have a lot of bleed off. This works really well. Personally, after having done a bunch of custom loop cooling, not hardline, but having done a bunch of custom loop cooling just for the purpose of making the computer quieter, I like this solution a lot because it's external. I don't really like having the reservoir internal because it's harder for me to keep an eye on it, but having this external makes it a little easier. In fact, I kind of want to mount this in the front so that I can just pop open the front and be like, oh yeah, it's fluid time, and sort of deal with it that way. Not having any connectors on the top means that this can be stacked with fans. Not having any ports on the top, you could use this port on the front to fill it, just pop the front of your computer off, unscrew this, fill it up, but you can't fill it up completely the way that you could if you had, tubing and an actual fill port. So my Threadripper system, I added a fill port and a tube, and that keeps the reservoir completely full. So every now and then I just look at it and say, can I see any fluid at all? Can I see the top of the fluid? And if I can, then it's time to top up because it's drained from the fill port to the reservoir and even a little bit. It's taken over a year for that much fluid to evaporate through the thing. So it's fine, basically. I love these. These are awesome. Now the only other thing that we could talk about is the radiator. Well, okay, the CPU block and then the radiator. I'll mention the CPU block really quickly. So CPU blocks in smaller form factor builds, those can be tricky as well. I wanted to give you an honorable mention for this. Oops. I wanted to give you an honorable mention for this Barrow. This is a block and pump combo, but it's for a custom loop. We got an in, out, and fill. This does sort of need a separate reservoir, or at least, a lot of tubing and fluid in the tubing to the fill port to make sure that it's appropriate. But you've got your in, out, and fill port actually on the pump. So you can mount this pump on your CPU, and ideally you mount the radiator above the pump. In this configuration for something like this, I don't know that I would want to put the radiator in the bottom of the case. That is one of the places you could mount the radiator, but I don't know that I would want to do that, just because you don't want the pump to be the highest part in the loop, because when you do get bubbles in the loop, they're going to go to the pump, and then the pump's not moving fluid, and you got problems. So this pump could work for a build where you've got the radiator in the front or the top, and the tubes sort of go below the level of the radiator, so that the bubbles are going to go elsewhere in your custom loop. This is a pretty cool solution. I'll also mention one other cool feature of this pump is that it has an LED screen here that'll show you some stats like temperature, RPM, and it's got some buttons on it so you can control it. This is a great solution for a small form factor build in either one of these cases, because it does everything. In a desktop case, I would not use this because you don't need to, because you have plenty of room. Special use case, totally usable. Now radiators can be a little tricky. Here I've got an EK Coolstream 240 millimeter radiator. You'd be surprised at the cooling capacity of a 240 millimeter radiator. There are some things that you should look for if you're new to this or you're going to attempt a small form factor build. One is, what's the distance between the radiator and where the fans are mounted? Some of these are really thin, and the radiator part is the same thickness as the rest of the radiator, and some give you a pretty good margin. So like on this one, this is a LC Solution Coolstream SE. This is one of the most inexpensive radiators you can get. It's from EK. The fin density is not crazy, and the cooling capacity is not the best, but this is more than adequate for even fairly substantial builds, even though it's only a 240 millimeter radiator, especially when we're talking about small form factor systems like this one. What you might not realize is if you mount the fan so that the fan is facing into the radiator, so that the back of the fan is on the outside, the fans can actually move on their hubs depending on what brand of fan that you have. So if you have a cheaper fan, as it ages, the actual fan part will move forward when it's energized, and also when it's working really hard. So it's sort of blowing air out the back, it'll actually move on its hub, and that sort of rubs and wears, and it'll slowly lurch forward. So the reason that you get the margin here between the radiator and the frame is that if you have a fan mounted so that it is blowing into the radiator, the hub has a margin to move and not bang against the actual radiator part of this. Of course, if you flip the fan around the other way so that the back of the fan is here, it's never going to bang into the radiator. But for a small form factor build, having both sides of this have that margin is maybe less than desirable, because you don't need it, and maybe you need those extra few millimeters. The EK solution is the idiot-proof solution. It has those margins built in so that you don't have to think about it as the inexperienced user. But there are other people that are making radiators, such as Magicool. This is the Slim G2 radiator. So if we take a close look at the Slim G2 radiator, we'll see that honestly it's not really that much slimmer than the EK radiator. It's really very little, and it's mostly the margin. The margin is about a third of what it is on the EK, but side on, it's really not a lot different than the EK. And the fin density and things like that, there's not really a lot of parameters of this radiator that are different. We've got sort of this separation here because it's gonna go down and back, so it's gotta loop through the radiator, but that's pretty much it. With one EK Coolstream and this one, you can fit both of them in the Incase M1, and that's 2 times 240 millimeters worth of cooling. That is enough for a 3090 and Intel's latest and greatest with Alder Lake 250 watt. Not a lot of fun to cable in. You gotta have fittings, you gotta have right angle fittings. That's a whole other dimension of crazy. We'll talk about that. But you can do it. Oh, but it's gonna be, not a lot of extra room. Now the difference between this and the EK radiator is just a few millimeters, but that just a few millimeters can be the difference between it fitting and not fitting when we're talking about ultra small form factor cases. Unless you're really, really good at reading diagrams, my best advice if you want to get into this and you don't want to buy a lot of stuff you don't need is to follow the builds that other people do, because there's a lot of enthusiasts around here. I don't know what it is, but people just get enamored with little cases like this. I mean, just look, it's so cute, it's so little, it's aluminum, there's so much stuff going on here. I get it. I get it. You know, saying, oh, look at me, I crammed a 64-core EPYC inside this thing with a 3090 GPU. Woo! 17 million hits. I don't know why that is. I get it. But, you know, it's just kind of the way that it is. So try to find something that's paint by numbers or choose safe choices. Now, blocks can also be a little bit weird and a little bit misleading. So, for example, I've got this EVGA 3080 FTW3. This is a custom design from EVGA. Look at this card. Look how wide this card is. This is crazy. If you check the dimensions of this card, it will say it fits in the Incase M1, and it totally does. This is a 3-slot card. It'll fit in the Incase M1. You won't be able to have any fans in the bottom, but this will totally fit in there. It'll also fit in the NR200. The problem is if you want to add this to your custom loop. EK makes this really insanely BA block for it. The problem is this on the side sticks out of the side of the case. The total width of this card is wider than our Incase M1 by a fair bit, as you can see there, because the motherboard mounting will be here. It's not gonna fit. If you do the quick disconnect kit from EK, you'll gain a few millimeters here, but not a lot because the connectors come in at 45 degrees on the side. It's not gonna work. The FTW3 is just not gonna work. It will work in the NR200 with just a little bit of finesse. You can do it. So the 3080 FTW won't work, but the 3090 Founders Edition will, and the 3080 Founders Edition will if you use the EK block. So this is the Bits Power 3090 block. I haven't even used it yet. See, I had a Founders Edition 3090 that I paid retail for, and the GDDR6 in it gave up the ghost because it was running at 95 degrees C all the time. It died. So if I ever get that fixed, I'm going to put a block on it if the repaired one still has the GDDR6 running at 95 degrees C, because oh boy, I'm sure that contributes. Like, long story short, I can get the card to work in Linux. It shows up, says everything's good. I can run some basic SMI diagnostics. Oh, error initializing memory. Yeah, GDDR6 has got problems. So if I ever get it repaired and the memory on the repaired one is still running at 95C, it's going under a block. This Bits Power block is like $200, which is crazy. But the connections are on the end, not the side, on the end. And that's the same with the Founders Edition 3080, the EK block, and other blocks. So that will work in this case, and that'll work in this case as well, because those cards are not super long. Having all of that be water cooled, oh, looking forward to that. So yeah, there's kind of a lot. You know, this isn't something I would even recommend that you do. Just build a standard size system. If you are going to do a custom loop, build it in the standard sized, you know, ATX desktop system, or possibly micro ATX. Doing it in an ITX system, it's not a lot of fun. And if you are going to do it, I suggest, you know, build by numbers. Put together a shopping list that somebody else has put together previously, and then build that, because otherwise you're going to need to be really careful with your measurements and planning and making sure that this will fit or making sure that that will fit. And you might very well be the first person to try it. It's possible. So be careful with your ultra small form factor builds. Know that there are really cool options like this Reservoir thing that can hang out on the back of your machine. I had no idea these were so cool and worked as well as they do. They are awesome. And they open up a lot of possibilities because they don't take up room inside your already space constrained. And they don't take up a lot of space in your already space constrained case. So it's something to consider. There's a lot of cool stuff. I mean, a lot of people, I don't know. I wouldn't recommend it. It's definitely not something that you should do, but at the same time, it's kind of attractive and a lot of fun. It's like building a ship in a bottle. Who in their right mind would think building a ship in a bottle would be fun? Why would you even build a ship in a bottle? It's hard enough to build the ship not in the bottle, let alone inside a bottle. Building a ship in a bottle is harder than building a computer, for sure. Definitely. But there's also something attractive about, you know, having 64 cores in something that I can palm. Admittedly, I probably wouldn't be able to palm it after it's in there because it's going to weigh about 4 million times more than that. But still, it's a lot of fun. I mean, it's something that you can do, and liquid cooling is one way that you can make sure that it's not going to run loud and hot and kill itself because it doesn't have adequate cooling. I mean, look at this graphics card. This is 3/4 cooling, and you're going to reduce it to something that's, you know, that big. But then you can put radiators and other stuff in the bottom, which was cooling for that, but it's more efficient because it's liquid, and you can also add cooling for all of the other stuff, and you can probably put another radiator somewhere else. So you got a dual radiator setup, so you got one on the top, one on the bottom. You know, whatever you're doing, it's a lot of fun. I don't know. This is kind of vlogish, just some random thoughts. The D5 pumps in general, these are more reliable because they're completely sealed versus the ones where you've got a connected motor shaft. The seal around the motor shaft is usually the thing to fail on those DDC pumps. The D5 pumps generally are more reliable. In terms of like water flow and other stuff like that, it doesn't really matter much for builds like this. They're close enough to each other at this point that it doesn't really matter. The noise is close enough that it doesn't really matter anymore. Historically, that was maybe something. If you get something super cheap from China, that might still be a thing to worry about. But, you know, SwiftTech is a pretty good brand. XSPC is a pretty good brand. These EK stuff, you know, EK is really trying to take it up a notch in terms of quality as a differentiator. Of course, there's also the cost delta. But, you know, the fittings and all of the other stuff for connecting the tube, how you want to do that. Is it going to be at a right angle, a 45-degree angle? There's a bunch of other little details for water cooling. It is a lot of fun to get into those, but you got to really dot your I's and cross your T's. You got to be detail-oriented to be able to plan and pull off a build like this if you're not just going to copy-paste somebody else's build. But it is a lot of fun. I'm Wendell, this is level 1. This is some rambling and maybe a preview of using some of these parts. I'm going to definitely try to build a small form factor Alder Lake 16-core build around some of this, and maybe even a 64-core Epic with water cooling. It's not insanely loud. Maybe with the 3080, maybe with the 3090, maybe with the 6900 XT if I can get a block for it. I'm Wendell, this is level 1. I'm signing out. You can find me in the level 1 forums. Hey, if you got a small form factor machine, come show it off. Love to see it.